Hello everyone, welcome to our course. This course is about NoSQL basic knowledge. Here, NoSQL is a terminology that refers to a big type of databases which are very different from relational databases like MySQL or SQL Server databases. So in this chapter, we are going to introduce some basic concepts and theories about NoSQL databases. And the objectives for this chapter is also very clear. We hope that after this course, you can be able to understand the development history of the NoSQL database and its representative products, understand the theoretical knowledge of CAP, and learn about MongoDB, Redis, Neo4j, and Cassandra databases. Now, let's jump into the first chapter, NoSQL Development History and Trend. To begin with, let's take a look at data storage in the computer age. As we mentioned, NoSQL is a big type of databases. So in general, NoSQL databases are still designed for data storage. But in fact, data storage technology has witnessed quite a long history of development. This graph shows you the rapid growth of digital data storage. In this graph, the size of the area represents the volume of data. And we can clearly find out that the data volume suddenly exploded in the year of 2000 and then in 2002. Because since 2002, the internet, cloud computing, and big data have been developing rapidly, and the amount of data behind them has been increasing sharply as a result. On top of that, we face not only the increase of data volume, but also the increase of concurrency, performance requirements, diversity of data types, and the emergence of new services such as data mining and data analysis. So in this graph, you can find that the storage media also evolves quite a lot. From the digital storage model being invented, we already learned how to use stones, bamboo, or paper books to record data. And after the third industrial revolution, we entered a new era with computers being introduced into our daily life. And therefore, writing data in digital devices became an urgent need. In that time, analog storage, including magnetic tapes and audio tapes, was the mainstream. I believe some of you still have cassettes at home, right? But cassettes as well as tapes are not sufficient when internet becomes part of our life. Thus, new storage technologies like soft disks and hard disks are introduced. And at the meantime, people's demand for entertainment has spawned the birth of CD, DVD, and Blu-ray discs. Up to now, we are still using hard disks for data storage, but now the efficiency and storage capability of massive data is the key point. All of this has forced us to keep optimizing and improving our storage devices to cope with increasing complex business needs. In a computer system, there are many kinds of data stored on disk. Generally, there are three types of data. The first is structured data, such as bank accounts and credit card balances, which are mainly stored in two-dimensional tables. The second type is semi-structured data, like HTML, XML, JSON, and YAML documents. The third type is unstructured data, such as audio, video, and pictures. So what you are watching now is just a kind of unstructured data. All of these different kinds of data reside in databases or stored in the format of documents or files. But at last, They are kept in disks, tapes, and optical disks, and so on. And talking about database, we can take a look at the emergence and development of database technology. Here we can see, before the mid-1950s, computers were mainly used for scientific computing. So at that time, people mainly used paper card or tapes for data storage. And they managed data manually. Then, from the late 1950s to the mid-1960s, there were direct access devices such as disks and drums in hardware. In terms of software, the operating system has dedicated data management software, which is generally called file system. Now, we are still using file system like Windows file system or Linux file systems frequently. After that, since the late 1960s, personal computers became more and more popular, and more data were generated as a result. But file systems are not good at random data accessing, plus the accessing efficiency is not very high. In this case, databases were introduced at the first time. Here, you can find some development trend for databases. From the hierarchical model to network model, and then to relational model. Now, we are still using relational databases in many industries because relational model is really easy to understand. A relational model can be simply understood as a two-dimensional table model, and a relational database is a data organization composed of two-dimensional tables and their relationships. Then, in the late 20th century to early 21st century, structured data occupied the absolute majority, and structured data can be managed and analyzed perfectly by using relational databases in the format of two-dimensional tables. Therefore, many famous relational databases were introduced at that time, like Oracle Database, SQL Server, DB2, MySQL, and so on. However, with the development of the Internet, there is more and more semi-structured data and unstructured data. This becomes a problem for traditional relational databases. Like pictures or videos, they cannot be explained by two-dimensional table. So traditional relational databases cannot meet this requirement. As a consequence, new types of databases need to be introduced. And in order to make distinguish, people give the new types a name called NoSQL. In fact, the idea of NoSQL originated from the concept of object-oriented database, such as MongoDB. And once the concept of NoSQL was introduced, it began to attract great attention. Simply speaking, it can handle all the three types of data, which means that it is more applicable to the requirements of big data cloud computing. And here, you may find another term called NewSQL. NewSQL is the recent development of NoSQL, which is a general type of various new scalable and high-performance databases. This type of database not only has the storage and the management capability of NoSQL for massive data, but also returns the traditional databases capability of supporting ACID and SQL. So we really talked so much about the history, but you might be wondering, what is NoSQL indeed? In fact, it is not easy to give a clear definition. Here, we can only say that NoSQL is a broad category of databases which provide different data forms and characteristics from two-dimensional tables. We will introduce 4 widely used NoSQL data models slightly later, so don't worry right now. And also, different people may have different explanation for the term NoSQL. Generally speaking, it is considered as the abbreviation of the following words: NoSQL, non-relational, or not only SQL. I prefer the last one because NoSQL databases can also provide services for relational structured data, which means that it is still a choice for SQL and relational tables. And again, as we mentioned before, at the beginning of the 21st century, the traditional relational model was no longer suitable. Therefore, no databases for survey scenarios were designed and developed. These databases formed the main body of the NoSQL database that we often talk about today. Here, you can find many famous NoSQL databases, including Redis, MongoDB, CouchDB, Cassandra, and so on. We are going to introduce many of them later. Because NoSQL databases offer good flexibility as well as high scalability, we can use them in many different scenarios. Like we can use them to store and analyze game data, social media data, IoT data, internet data, mobile devices data, and some data from many IT enterprises. And below, we can find 4 terminologies which are actually the most widely used types of NoSQL databases. In the following several chapters, we will introduce NoSQL according to these 4 types, so they are one of our main topics in this course. But someone may ask, there are so many different kinds of NoSQL databases. How can I find a NoSQL product that can meet all our requirements? The answer is that you can use multiple NoSQL products together because no single NoSQL database can meet all your needs. For example, if your business data changes quickly and your database size is predictable, then you may consider using Redis. If you want high availability of data, minimize the risk of data loss, and support linear expansion of the entire system, you can use HBase. In general, NoSQL mainly addresses large-scale, high concurrency, and frequent expansion of services, and different scenarios may have different requirements for different products. And finally, there are some key features of NoSQL. Firstly, NoSQL data is partitioned, and a large number of nodes are used for parallel processing to achieve high performance. In addition, the scale-out mode can be used. Secondly, NoSQL reduces the ACID consistency constraint. Allow temporary inconsistency and accept final consistency. Usually, it complies with the CAP theory or Bayes principle. Finally, each data partition provides backups to cope with node faults and improve system availability. Alright, that's all for this chapter. In this chapter, we introduced the evolution history of computer data storage systems. Different forms of data exist, definition, development, and scenarios of NoSQL, and finally, some key features of NoSQL. Hope you guys enjoyed all the contents in this chapter, and see you in the next chapter.